Hi, everyone. Thanks to everyone for joining our webinar today. So my name is Gavin Newlands, and I'm the product lead for the Oasys LS-DYNA environment. Our webinar is a little different today in that we have a presentation from the perspective of a new user of our applications. So note, we'll be recording this webinar, which will be available on our website soon. You have the ability to type in questions as we're going along, so please do so, and we'll try and answer them at the end. So I'm delighted to introduce our speaker today, Michal Sobota from MESco in Poland. So Michal holds a bachelor's in mechanical engineering and completed his master's in mechanical engineering focused on modeling and optimization of mechanical systems, both from the Faculty of Mechanical Engineering and Technology at the Silesian University of Technology in Poland. So Michal's expertise at MESco includes conducting all kinds of analyses using Oasys LS-DYNA. So his main topics of interest are analyzing dynamic phenomena, utilizing meshless methods, performing highly nonlinear analysis, conducting coupled thermomechanical analysis, and modeling detonation and deflagration. He's also skilled in geometry processing and preparation, as well as creating numerical meshes for the explicit method while providing technical support for clients. So I'd like to hand over to Michal now, who will talk through his experiences of using Oasys LS-DYNA environment as a new user. So Michal, over to you.
Hi everyone, thank you Gavin for the introduction. So yeah, so let me just quickly go over what I want to show you in this webinar. So as the title says, a new user perspective. So as Gavin said, I am the new user of Oasys Suite, but I am not a new user of Oasys LS-DYNA. I've been using LS-DYNA for about more than 3 years now, but I've been using Oasys Suite for less than a year. So between that time, I can really pinpoint the advantages of the Oasys Suite in pre- and post-processing my files using the Oasys Suite. So let's just quickly go over the company that I work for. So we can be called an engineering company, MESco. We are based in Poland. We have been on the market since 1994. So this year will be our 30th anniversary. We can be called mainly an Oasys channel partner for Poland, but also we offer other software such as RockyDem, ParticleWorks, and since recently Oasys Suite. Currently we have 23 employees, which is not a lot, but we are actively growing year on year. And for our clients, we of course do support work. We offer them our expertise. Also, we do projects for them in all kinds of physics, beginning at the mechanical FEM analysis, going over the fluid simulation in CFD, and also doing electromagnetism and high frequency analysis. We also partner with our technical universities in Poland and with their student teams, and we offer them our software to better prepare them for work in analysis. Okay. Also, I want to quickly tell you about our annual conference that we call Simulacja. This is for our Polish customers. So this year will be the 19th edition. Each year we have about 100 attendees from 40 different companies that use our software and are based in Poland. And also we work with 5 universities. And on this conference each year, the attendees can listen to our presentations, attend some workshops, and also take part in live demo. If you are interested in our company, please visit our website at this address, but I will also show you this address at the end of my presentation. Okay, so thank you, Gavin, again for the introduction, and I will tell you about again what I have been using LS-DYNA for. So as I said, I've been using LS-DYNA for more than 3 years, and in that time I've been involved in many parts of the LS-DYNA software. So beginning at the basic crash simulations, I've done some work on those. Also, I've been involved in static and quasi-static simulations. Also, recently I've been focusing more on manufacturing processes, such as one on the top right corner. Here we can see a static simulation using SPH method. And also I've been modeling explosion and blast in LS-DYNA using ALE keywords. So here we can see a shaped charge projectile being generated by explosion. Also, I've done some job on civil engineering and offshore industry, and even in bioengineering. And also, I've worked on coupled analysis, especially with coupling mechanical and thermal analysis. So in order to show you what I've been using Oasys Suite for and where it has been useful for me, I want to show you an example showcase model that I've been using Oasys Suite in. So here we can see a structure called artificial shaft bottom. This structure is quite big because here we can see that the diameter of this structure is about 9 meters. It is positioned at the bottom of the mine shafts, and when the workers want to deep below the existing mine shaft, they install this artificial shaft bottom at the bottom of the well to protect them from the falling debris from operation in the other parts of the mine. So let's just imagine that the workers are trying to excavate below the this structure, and the miners working in the other part of the mine accidentally drop something, some kind of structure at the bottom of the well. So after falling, this structure is supposed to catch the debris and dissipate the energy so that the miners at the bottom of the well are safe. So this is the model that I've been using Oasys Suite for. So in order to show you, I will go over the primer and show you what the model looks like and what the results look like. And the first thing I want to point out is the speed at which the Oasys primer loads the model. So in less than a second, I can load the entire model. It's not a small model, as you can see when I turn on the mesh. And the first thing I want to show you is the results before we go over the primer functionality. Okay, so I have quickly opened the diffreeplot window in which we can go over and see the results. So let me just position that right and play the animation. As you can see, the animation is smooth even for that large model. We can see some beams breaking. Those are the ropes, the steel ropes that are catching the debris, and the debris right there weighs 20 tons. So it's a pretty heavy piece of equipment, and we can see that our structure is catching and dissipating the energy of that equipment. The height of the drop of this equipment is about 1 kilometer. So it's a pretty fast moving object to catch. Okay, so let me just go over the primer and show you where I have been using primer to my advantage. So first thing I really like about the primer is the way it handles include files. So let's just go to the include files, and you can see that I have 3 include files in this file. And if I go over and hide my thumbnails, of course I can still see them, but if I go over and show them, you can see that the third one has an empty window. So if I go over and go to different view, now you can see that the third slide, the third input file has some parts in it. So I can also go over and show only this keyword include file, as you can see, and I can quickly modify that without other structures obstructing the view. Okay, let me just go over and show you another feature that I really like and has been really useful is the option to automatically change the units of my model. So let's just say that some of my colleague has prepared a model for me to include into my main file, but he has used other units that I do not use. And right in this window, I can specify what parts of my model I want to change units in. So let's just go here. I will select one of the keyword files. Let's let it be middle.key file. Okay. And after that, let me just go over and change the units that I have in this keyword and change the final units I want the keywords to be in. After that, I just click apply and Primer will show me the parts and the keywords that it will change in order to match the units in both of the models. So this is a pretty useful tool. I will abort that. Okay, another useful feature I want to show you is the one using automatic error determination while specifying some of the keywords. So let's just go over the keyword file and let's just try to modify some contact in my model. Let's go over and choose automatic nodes to surface model. I will close the one I've accidentally opened. And let's go to the other cards that are available. And let's just say that I want to set my soft parameter to 2. After going that, I can check if the definition suits my type of the contact. As you can see, Primer will tell me that there is a possible error in my input because the soft equal to is not supported in nodes to surface contact. So right now, I can quickly check if my model is set up correctly, even before going over the total, so the main checking functionality. Okay. Another thing that I really like is the automatic shortcut generation. So after hitting a question mark on my keyboard, this window will pop up and all of the shortcuts that are available to be created in Primer are displayed. So I can quickly create my own custom shortcuts if I'm used to other layout of my shortcuts and use them in my model. So it is also a very powerful tool in Primer. Also, I want to show you the functionality that I have never seen before. It is located under the Mesh Tools, under the Morph option. So let me just unblank all and just go like that. And let's say that I want to parameterize my model in order to see what kind of influence does the shape of the body that impacts my model have on the results. And I want to create many models and find the one that generates the highest piercing force. So I can use for that the morphing tool. Under that, let's just say that I want to morph a part. I will click on my part and create a box. And using that box, I can create some morphing keywords that I can then export to the LS-opt program that can generate and run optimization analysis. So by using the face functionality right there and specifying the axis that I want to morph my model. I can just drag the handle and my model will be automatically changed. So as you can see, I'm dragging the mesh, and the primer will remember what I did if I specify that under the variables tab, and then those variables can be exported, as I said, into LS-opt. Okay, so that has been really useful in my work as well. Also, I want to start a new primer session and show you another amazing feature under the include files. For that, I will open another model because unfortunately this model does not really show what I want to show greatly. So let me just open an automotive model of a car, and after I will go to the include window. Also, I will refresh my thumbnails. Primer will allow me to show those thumbnails, and after clicking on the specified include file and going over the show connection tab, Primer will calculate which parts of the given include files are connected with other include files, and I can quickly pinpoint the possible errors in my model and where I have to pay more attention in. Okay, that was it, so I can close the window. Also, and another great feature that I want to show you is the workflow tab that has been really useful for me. So after going to the tools, and let's go just to workflows. Let's say that I want to create some entities of interest that I want to automatically display after launching the free plot. So I can just click on parts, select some parts. Let's just say that I want to select ropes, apply, save to file. I will quickly save that. And after launching the free plot, I can go over here, go to workflows, and show my entities of interest. Right now, we cannot see them because the beams are not displayed properly, but the primer and the free plot allows us to quickly type in the command that we want to see, that we want to use. So let me just type beams and tell the free plot that I want to through section of the beams to be displayed. Right now, I will just tap on the Y key to hide the mesh, and you can see that the beams have been highlighted in my model, and we can see how they are breaking in my model. Okay, I will open another diffreeplot file in order to show you another great functionality, that is the possibility of creating my own GUI builds. So let's just go to the default file, and under the JavaScript, I can go over the file that I have created before. And after clicking run, this is the GUI that I have created. So I had many parts that I wanted to calculate the gap between. So I created this GUI in order to quickly change my elements of interest. So I can type in, let's say, the thickness of my shells in my model, and then just go over and click off the parts that I have created and that I want to measure the gap between. Just click on measure gap, and the primer, the diffreeplot will generate the plots of the gaps. for me. And this functionality has been possible for me before under the option of scripts. So of course I could just run the macros for that, but macros are really not that customizable. So of course I have the possibility of creating a macro, of recording a macro, but given the GUI builder, my analysis can be much more flexible for that. So I've been using macros before, but using the GUI builder has helped me a lot in post-processing of my files. Okay, speaking of post-processing, let me just open another diffplot file and see the analysis that has not enough frames in it. So I will open this analysis and you can see that the model ends here. So if I zoom on the model, even if I slow down my animation, something like that, you can see that the display is really choppy. And I don't want to send this animation to my client because he will tell me to increase the frame rate. So what I can do is go over and interpolate the results between my frames. So let me just increase 10 times the number of frames that are available in my model. And after switching the delay to no delay, I hope you can all see how smooth the results are in order to see the correct information. So without having to increase the number of frames, I can quickly interpolate between the results and have a much smoother result here. Sometimes, especially in manufacturing problems, in quasi-static solution, it may be difficult to assess if I should use explicit or implicit method for my model. Let's say that we have something that takes 10 seconds to create something like a sheet metal forming. So it may be great for me to quickly switch between explicit and implicit models to see which one will run faster. It may happen that the implicit model is running much faster than explicit model. And in order to quickly do that, I can just go over the implicit tab here, and primer will allow me to quickly change from explicit into implicit model. Let's just go over and say that I want to use advanced options and I want to go into transient analysis. The primer will help me to prepare this model by allowing me only to change the parts that I need to change in the include keywords, into the implicit keywords, sorry. Okay. Let me just go over back to the results and show you how I can quickly generate the cut sections by clicking the X on my keyboard. Then I will just specify that I want to use constant Y. Go over and click on my part. Let's just be that. After that, I want to omit this part and see that as normal. And as you can see, I have my cut section here. But what happens if I want to change the location? I can just click on the D part and drag my cut sections into the place I want it to be. Okay, another great feature is, let me just switch off that. Let's just say that I have two models and I want to quickly show the difference in results between those. So I can just open a new model and let's just say I want to open a model that I have shown you before. So diffplot will open two different files for me. I just go to window and show them both in one window. And after that, I can also change the display of this window. So let's just say that the first model that I have loaded, I want it to be a specified color. Let's let it be red, and another model will only be displayed in green. And after applying those changes, you can see that right now those models are the same, but after running the analysis results, we can see that those models behave differently, especially here near those beams. We can see that right now we have a difference of a couple of millimeters in the displacements. So that is also a really powerful feature for me. Okay, I will close this session and open another one and show you another great feature, that is the deleted elements workflow. So I can go over and show only the eroded elements. Also, I can highlight them. So if I go eroded elements in red, I can highlight my eroded elements and exactly see where are those and at what time are they being deleted. So after running the animation, you can see that all of the shells have been deleted. Also, the beams have been deleted as well. Okay, another great feature in Oasys Suite is the ability to quickly submit the full restart files into the LS-DYNA solver. So let's just say that I have some model. Let me just go over and include a file. And after going into the restart tab, the solver will quickly show what kind of analysis I have here. And primer will, sorry, not primer, but shell will show me the dump files that have been generated here and allow me to create a quick restart analysis from that ability. So I have to switch to SMP solver, and after doing that, you can see all of the restart points and even the time that the dump file has been saved at. After clicking on given dump file and specifying that I have created a restart file in the input deck, I can just quick submit and the full restart will be started. So that has really sped up my model preparation. Another great feature is, of course, the ease of use of reporter. So let me just start a reporter session. And in that, I can open a predefined template. So let's just go to my template files and see that I have my template created here. Right now it is empty, but let's just say that I have created this template before I have run my analysis, and after analysis I want to create the report, or maybe I have done some changes in my model and I do not want to create the whole report for my client from the beginning. I can just quickly tell the reporter where those the job results are. Let's just say this is the location of the files. Let's just say this is it. Okay, and let's just go over and generate the result. It will run the diffree plot on the window. After doing that successfully, we can see that in one click I can generate a screenshot that I have predefined. Also, when it comes to plots, it's the same story. And in just 2 clicks, I can quickly update my reports for the clients. It's especially useful when I do a lot of reports. Another great feature is generating reports in batch. So let's just say that I have run my morphing analysis using, let's just say, 5 different load cases. After going into the batch option under the shell and showing the shell where my results are. So let's just go to the report generating. I have 5 folders in here. I have to quickly change from input list to input directory. Also, I will show shell where it should search for the results. Also, I will create for each of the reports the same template. So I go over and click on my template, and I just go over and read all the results and apply the template to all of the results. And by just clicking run reporter, it will generate 5 of the reports. Each will be different because I have different results in those files, and even I can combine them into one PDF file that I can then send my client, and my client can see what difference are between each of the load cases. So it was also a really powerful feature. I didn't have to spend much time on creating those reports by hand. When it comes to my clients and showing them the Oasys Suite, they really like the sort of new capability of Oasys, and that is the D3 plot viewer. So let's just say that I have my animation right there, and I want to send it to my client, but my client doesn't have the Oasys Suite installed, and he also wants to see the 3D results on his computer. So I can just go to viewing, images, D3 plot viewer, and create a custom D3 plot viewing file. Let it be a frame rate of 60, and after clicking capture, D3 plot will generate this file that I can then quickly send to my client, and my client can just drag the model that I have generated on his computer into the website, and after loading that, we can see all of the results as an animation that my client can rotate. He can then create some cross sections, and he can really manipulate the model to see if the results are correct or not. So it can greatly increase the speed in which I have been communicating with my clients, because I don't have to specify a Teams meeting to show them the results. I just quickly send them the link to download this GLB file, and then they can on their own manipulate the model and see the results on their computers. Okay, so after that, I want to also show you the checking in all Oasys software. So I will close my primer session and start a new one in order to see another great feature. So I will go over and open my default file of the artificial well bottom. And I have run my simulation on 32 cores using MPP solver. So I can just quickly go over the check tab, click on LS-DYNA, and search in the existing results. After that, Primer will see the results files and can display for me the contact profile, load profile, and message profiles. So those bars represent how has the load of my model has been, how my model has been subdivided onto each of the 32 cores of my machine, and if each of the cores is being loaded in the same way. So I can see that looking at the results and also looking at the how much time does the contact algorithm take and how much element processing takes. Those are two very time-consuming aspects. I can quickly see that my model is being greatly subdivided into each of my cores. So if I see any of the different bars here, so let's say that my bar has a different length than the bar representing other core, or let's just say that contact is taking 90% of the time on one of my cores, I can quickly find some errors in my subdivision on the cores. So it was another great feature to use for me. Also, I just go back to the model and go to check file and go to element quality. So in the element quality, I can go over and first of all, under the options, I can specify that I want to check my model into all of the specified predefined criteria, and I can manually define what those criteria should be. And after that, I can choose run the element quality check, go over failed criteria, and display which element has failed which criteria. So as you can see, I can just go to Jacobian and see which elements have failed the Jacobian check. After that, of course, I can just go over and click on node drag and try to drag the node so that as you can see, the Jacobian is being satisfied. So it's interactive. That is also great. So basically, that will bring me at the end of my lecture. I think I've shown you all of the features that I have been using Oasys Suite for. It has, as you can see, it has greatly increased the productivity in preparing and post-processing my models. And yeah, I think without that, it would take much longer for me to generate those results. So I will just quickly tell you how I came to know Oasys Suite. So one day after using some other software for preparing my models, I have run out into many problems with stability. So after comparing some models that I shown you before, the software would crash. So I just couldn't work with it anymore. So after that, I just emailed the Oasys team for a quick demo, and they provide me with the Oasys Suite. And I fell in love at the first time because the stability of the models that I have been pre and post processing has been great. And using this model, I have never had a crash. That was not true for other software that I've been using before. So right now, let me just go back into the presentation, and if you have any questions, please ask them right now.
Thanks, Michal. That's really interesting. Thanks very much for that. Yeah, just to reiterate that, if you want to ask any questions, please do type them in, and we can answer them as we go along. Yeah, it's really great to see the variety of tools you've used in your workflow, from the checking tool to automating things using scripts, and it's interesting to see the variety of tools that you've used. And some of the tools I would class as more advanced, and so it's interesting that you know, you use the tools that you need to use for your particular workflow. So you've shown how you created your own GUI because you needed to do that, and the morphing aspects and so on. So it's really interesting. And with morphing and LS-Opt, it's worth noting that there's native support now for Primer within LS-Opt version 7. So we've got some questions of our own here for you as well. So I've got my colleague with me as well, Galal Mohammed, who's an Oasys LS-DYNA application engineer. I'll just ask one simple question first. So what do you think is your favorite feature within the Oasys tools?
It's a really tricky question because it depends on the workflow that I use. But in Primer, I would say the morphing because it really shocked me how flexible the generation of files can be using the morph tools. Also, the diff-free plot viewer was something that I didn't expect was possible to do, just to quickly send my client a simple file and he can, without installing anything, see the results. And when it comes to creating reports, I would say the batch optionality to quickly generate options, the reports is also great. So those three are my favorite, I would say.
Excellent. I have a question. I was just intrigued that this is obviously a new user's perspective. What was the sort of learning curve like? How long did it take you to become sort of proficient and fluent in using our tools? As Gavin mentioned, there's quite a lot of tools and features in our software, and from the pre-processing and the post-processing side. I was just intrigued how long it took you to sort of familiarize yourself with all of those tools.
Yeah, so for a basic knowledge and basic using of the Oasys Suite, it took me about 1 week just to know where to click and how to load my model. And I'm each day basically using Oasys. I learn a new feature, but I want to show you one thing that I really like. That is the question mark in almost every single feature that is in Primer or other tools. I just can go over and click manual, and it automatically goes over the functionality and explains to me how to use that feature. So that, I would say, in combination with the YouTube channel that you have, has greatly decreased the time that I have to learn the new features. So I would say, for me, because I'm a quite advanced user of LS-DYNA, it took me 1 week, and to be really fluent about 1 month. But yeah, without that help feature, it would take me much longer, I would say.
Brilliant.
Okay, great. Thanks, Michal. Just on the subject of saving time, this is probably quite difficult to do, but can you quantify how much time you would save by using the Oasys tools to perform a particular task, to get to a model that you've run and debugged and so on?
Yeah, I mean, it's pretty case dependent, depending on the model and depending how much loading scenarios that I use. In simple models, I would say it's about 20% decrease in the time it takes me to create a model and process it. But when it comes to large models, let's say that I have 20 or more load cases, the automation tools can decrease the time by a factor of 2, something like that. So it's really a great jump, I would say. That's why I use it.
Great. Yeah, sure. Great. Thank you.
Yeah, good. Yeah, just at the start of your presentation, you sort of outlined all of the sort of projects you've worked on, from Crash, Civil, Blast, etc. I was just wondering if there's anything in particular in our Oasys suite of tools and features that you'd like to see sort of further developed or sort of introduced in our software in the future, based on your experiences.
I would say that for me, let's just go over and show you that the mesh tools right now, the functionality, I would say, is good, but I think that it is not suitable for me to create the model, the mesh from the start in Primer. So I use third-party software for that, but if it can only be used, it can only be created in Primer, that would be, I think, great. So yeah,
Okay.
I would say that the meshing is what I want to be seeing developed.
Okay, thanks for that. And we've actually had a question come in, which is a question on the particular models that you were showing. And the question is, how did you anchor the circular frame to the mining shaft? Did you use rigid restraints and design the anchors outside of LS-DYNA using the reactions?
The question, great question. So as you can see in this slide, the circular ring around our beams is being fixed to the walls of the mine shaft by a beam connection, which has a SPC constraint at the other end because the beams are being drilled into the rock. So in this model, for a showcase purpose, I didn't show those cables, but yeah, I use cables that are being drilled into the walls of the mine shaft.
Great, thank you. And just a follow-on question on that. So you talked about the models that you've used and having being able to handle those models within the Oasys tools. How big are the models getting that you're handling, and you know, do you have different sizes of models, smaller models, big models?
When we are talking about number of elements, I would say that the biggest one was 5 million elements. So using the primer, it was very smooth. I can always just hide the elements that I don't need to see. But yeah, I also shown you the DFreeBuild and that I can import 2 different models into DFreeBuild and see the results between them. So if I load in 2 models that use 5 million elements, then I have 10 million elements, and so on and so on. And I can go over those hundreds of, maybe not hundreds, but millions of elements and still have a smooth experience.
Great, thanks.
Good. I guess I have one last question. On the D3plot viewer side, have you seen much? Have you had sort of much interaction with clients, and what has been their sort of feedback in sort of sharing those GLB files with clients? Some of whom may not be sort of Oasys users or proficient in our Oasys software.
So the clients that I have sent the DFreeplot viewers files to all said that they are great. They also have seen that there's a possibility to seeing the reports in the browser. So besides showing the simple animation, I can also embed this animation into the report file and also go over the report viewer and have the whole report with the animation sent to them. So yeah, I would say on the side of my customers, the DFreeplot viewer functionality is their favorite feature.
Thanks.
Okay. Great. I think we'll start wrapping up there, Michal. So just a note to everyone in the audience, if you want to find out what webinars are upcoming, please do visit our website, where there'll be a list of upcoming webinars as well as training courses as well. And as Michal says, our YouTube channel is a really useful source of information, and you can also sign up to our newsletter and sign our LinkedIn group through our website as well. So that's a useful way of getting information. Or please do reach out to MESco or our other distribution partners for any more information that you might want about the Oasys LS-DYNA tools. So just to wrap up, thanks to Michal for his interesting presentation today. It's great to see how the Oasys LS-DYNA environment is being used at MESco, and fantastic to see how useful the tools are in producing quality LS-DYNA models and results. So thanks again to Michal, and thanks to the audience today for attending this webinar. So thank you, and we'll close there.
Thank you.